Hi, and welcome back to the FreeFlyer Expo. Thanks everyone for being here. My name is Julie Peck, and I am going to be talking today about Atlas displays. So I'm a member of the FreeFlyer technical support team, have been for a few years now, and for the last year or so, I've also been working on developing Atlas, specifically the iteration for Sierra Space and their DreamChaser program. So we're going to be talking about the concept of Atlas overall. We're going to be talking about Sierra Space's specific iteration of Atlas, and we're going to take a look at a demo. So what is Atlas? Atlas is essentially your big board display capability. We create custom displays for real-time situational awareness. You can see the image that's on this slide is of an Atlas display up and running at Houston in their control center. Atlas handles live telemetry processing, so it gives you that real-time capability. And we treat Atlas as both a product and a service in a way. We work directly with our customers to create visualizations that are specific to their mission's objectives. So we're going to see a few different examples of what that's looked like over the years. But the point is that it's a very customized service that is built by us to do exactly what your mission needs. So we're going to take a look at a few previous applications that have used Atlas, and then we will talk in more detail about the Sierra Space iteration. So this first example was for a GEO commercial comms satellite. We can see here that we have a few different sensor views. We have some Earth boundary layers. We've got blocks at the top to indicate the current status of telemetry data, whether we're in an eclipse, whether we're maneuvering, all of those good things. So this is a display that has a lot of visual components and also a lot of information on it, just in text form. This is a plot-heavy display. This was built for a constellation that was performing a low-thrust ascent to get to orbit. So we can see we have 4 different plots here, and for each of them, we're plotting data for multiple satellites, not just one. So Atlas can be used for a single satellite or a big constellation, whatever you need. In this one, we can see a similar structure to the GeoCommSat with all the text-based information at the top. And in this case, it contains data about the propulsion status, about current maneuvers, and total delta V. This one is one of my favorites. This is the ISS Proximity Operations Simulator. So this display was built with the FreeFlyer Runtime API using Java, and it allows you to simulate maneuvers while in proximity with the International Space Station. So we can see we've got a couple of 3D views in this display that are showing what our future and past orbit would look like if we perform different levels of maneuvers. And we've also got a sensor view that's close up on the ISS because that is what we're looking at. Finally, we've got an Orion mission display. So this one, we've got a moon view. We've also got a 2D map of the Earth that has been customized according to our operator's preferences, and as well as a 3D map that has different line layers for areas of interest and things like that. So Atlas can be used for, just like FreeFlyer, can be used for Earth-based missions or interplanetary missions, missions to the moon, and other bodies. Okay, so that's kind of what previous iterations of Atlas have looked like, and that's just a small sample. We created a lot more of these big board displays for various missions, but the one that we're working on most recently is for Sierra Space and their DreamChaser mission. So we can see here that on the right-hand side, that's the home page of Atlas, which we'll see in our demo in just a minute. And on that page, we have telemetry configuration options, and then we have 3 big displays, and we call them World Map, Relative Motion, and CCVT, where CCVT is our communications and coverage viewing tool. So again, every single version of Atlas has been a little bit different. The current architecture is that it's an application built on Electron and Svelte for the UI. Atlas handles incoming telemetry via a WebSocket connection. So the telemetry provider, whether that's simulated or real-time telemetry, sends that data over a WebSocket connection and it's received by Atlas. Atlas also handles processing user inputs for customizing the displays. So an important part of the requirements for Sierra Space was that they're going to have a bunch of different operators who are going to want to see maybe different ground stations or different teacher satellites in their displays. And so they want to be able to easily export and reload different configurations per operator. So we've built that in as a JSON file capability, and we'll see that in a minute. But you can basically save off your user inputs for whatever type of display you wanted specifically and load that in just through a JSON file instead of having to reset every single parameter. Once Atlas has all of your user inputs and telemetry data, it's passed over to FreeFlyer for visualization. So the FreeFlyer mission plans are launched as child processes from Atlas in JavaScript, and the telemetry that's coming in is streamed continuously via a socket connection to the mission plans. I should say these displays can also be run with ephemeris data. So what we're going to take a look at today is just using ephemeris data rather than telemetry, just for speed and because we do not have a simulator running right now. So we're going to see this live in a minute, but this is the telemetry configuration page. That's the first page of the Atlas display. And essentially what you can do here is provide all your different telemetry mnemonics. I just wanted to talk a little bit about how it works. Atlas takes all of those keywords, which are input in those white boxes on the screen there, and it creates a string request to receive data from the telemetry provider. So this is customized to build exactly the string that Sierra Space's telemetry provider is going to be expecting, and then that data can come through the socket connection. This page right now, it just says awaiting telemetry, but as telemetry comes in, it also shows you the time that the last data was received. So that can be really helpful to be aware of whether you're working with stale telemetry or how long it's been since you last got a data point. That can help you identify, whether something might be wrong with your connection. So I'm going to step away from the slides and get into some demonstrations of these displays. I do have images of these in the slides, but it's a lot more fun to take a look at them in person. So I'm going to go ahead and open up Atlas. Atlas can be run either from the command line or just by double-clicking. It's an executable file. So I am just going to double-click on my executable right here, atlas.exe. I'll hide my PowerPoint so that it's a little bit cleaner. We can see that home page that we were talking about. So we have DreamChaser is the mission that these displays were built for. The first page is what we just took a look at. That's our telemetry. So this is where you would input all of your telemetry mnemonics that the streamer is going to be expecting in that request. So in this case, I've just got a few filled in just with sample values, GPS weeks, seconds. In this case, our chaser is DreamChaser and our target is going to be the International Space Station. So these might be the values that we have to represent each of these Cartesian parameters. This would be for DreamChaser, this would be for the ISS. There's also a whole lot more telemetry parameters that can be handled by Atlas. So in this case, these were all given to us by Sierra Space. They said, this is the information that we're expecting to be receiving through telemetry, and we want to be able to build aspects of our displays around the current GNC mode, perhaps, or based on the spacecraft's attitude. So all of this information can be specified with a telemetry mnemonic, and then it can be received by Atlas and passed to FreeFlyer for the display. I'm going to go ahead and close this now. We're going to be running with ephemeris files today because our simulator is not up and running for the time being. So the first display is the world map display, and this is what the input configuration looks like for pretty much any of the Atlas displays, they're all a little bit different because they're all showing slightly different things. So for the world map, this is kind of our most basic, just general situational awareness display. We have a 3D view and a 2D view that we'll see in a minute. And here's where you can customize all of those different options. So you can choose your 3D model file for DreamChaser, a 2D icon for the map display. You can choose whether you want to run the simulation with telemetry data or with an ephemeris file. And if you choose ephemeris, then you can browse just in your file explorer to find the proper ephemeris. We have similar options for the ISS here, as well as a bunch of display options. So in this case, we're just turning on and off different aspects of the display and uploading an events timeline, a comm schedule, so that we can indicate when events are happening on the map. On the right side, we have the asset definitions box, and this includes places for you to add different ground stations, just as FreeFlyer object files, which you can export directly from FreeFlyer. DSN stations, same format. MOA zones are military operation area, so there are zones where you may not be able to be running communications because of a military blackout or something like that. You can specify those in here as well, and you can add ephemeris files to model the TDRS network at the same time that your DreamChaser and ISS are running. These buttons at the top are what we were talking about with being able to export configurations or load different configurations. If I were to export this, I could just save this as a JSON file in whatever directory I wanted, and then I could reload it easily, and it would have all of the inputs that have already been specified here. So I'm going to go ahead and hit run. And what this is going to do is launch FreeFlyer in the background, and it will pop up in just a minute here. If you run this from the command line, you'll see the general FreeFlyer output that you would see if you're just launching FreeFlyer directly from the command line, where it tells you, oh, I'm loading a mission plan, I'm registering a license, all of that good stuff. So on this display, we're loading in all of our asset data. We've got that represented in this console window down here. And then this is our big display. So we have a 3D view at the top that has just a large view of all of our assets. And at the bottom, we've got our 2D map that includes all of our ground stations. And we can see we've got an indicator here in purple for our next TDRS AOS. Very exciting. These displays are just like any FreeFlyer display. You can manipulate them just like you would in a FreeFlyer output workspace. You can zoom in, you can zoom out, you can change the target of the display. So if I wanted to focus on DreamChaser, I could just open the properties editor here and change my viewpoint. So maybe I want to zoom in on DreamChaser instead of being centered on the Earth. And here we are. Got a few vectors attached to the spacecraft to indicate different locations of interest, like the moon, the sun, the ISS. And then, of course, to get back to a normal display, just like in any FreeFlyer window, you can click Reconnect Automation, and that will reset you to the default in script. So that's our world map display. I'm going to go ahead and stop this one running. You can stop it just by closing FreeFlyer, or you can stop it directly from Atlas by hitting stop. I'm going to close this one, and we'll move on to the relative motion display. This is a really cool display. So this is designed to show data specifically for rendezvous with the ISS. So what we do here, we've got similar types of inputs, but a little bit different because the display is going to show different things than the world map. Again, you can choose ephemeris or telemetry. If you choose an ephemeris, you also have the option to specify an attitude history file. We can choose whether we're plotting predictions. So on our relative motion in-plane plot, we can actually plot out what we expect the orbit to look like if there were no maneuvers, or if we're going to have a pre-canned maneuver based on our GNC breakout mode, things like that. Similar asset definitions box as what we saw for the world map. I'm not going to add anything fancy in here, just going to leave it at the defaults for now. And I'll go ahead and hit run. We can get this launched. You can see under the plot section, there are a few different plots that we could load in for the relative motion display, but I'm just going to focus on the in-plane one right now because I think it's the most interesting. So similar to the world map, we've got a console down at the bottom that's showing some different log messages. We're just loading in our 3D model data and rendering everything right now. So here's our 3D view. This one is already centered on DreamChaser, and we've got two sensors here just kind of notionally modeling a star tracker and a LiDAR perhaps on the spacecraft. We've got two sensor views for each of those below, and you can add more or fewer as desired. The in-plane motion plot over here has a red line that indicates the planned trajectory for DreamChaser with respect to the ISS. So in this plot, the ISS is always located at 0, 0 at the center. The blue represents the actual points, and it's being overlaid on top of this red line right now because, of course, we're just propagating from an ephemeris, so it matches up perfectly well with what we planned. The yellow dots are the predicted trajectory. So that is just propagating the spacecraft ahead by a couple of hours. Those are options that you can choose how long that's propagating and at what fidelity in the Atlas inputs. And that's showing what our trajectory would look like if no maneuvers happen, just with a simple two-body propagator for speed. If a burn's included in telemetry as well, this display can handle that and it can model the burn in this predicted trajectory. So this one takes a little bit to run, but I actually have already kicked off another run of this same mission plan, just standalone from earlier. So I'm going to open that up, and you can see we've gotten a little bit further along our planned trajectory here. And I wanted to show this off because I wanted to see closer to the end of the actual rendezvous. So as we can see, we're inching closer along our planned trajectory. The eventual goal is to dock with the ISS. So we end up at 0, 0 on this plot. And we're just zooming in on the plot as that becomes more relevant. Trucking along, performing attitude adjustments, things like that. We can see the ISS is over here. We'll talk about what those little bubbles mean in just a minute. As we're approaching the ISS, there are different safe corridors that Sierra Space has provided to us that we are modeling here in the plot. So what we want to do is see our spacecraft stay within these safe limits. And we've also added this position constraint plot to demonstrate those in another way. So you can see the DreamChaser moving through each of these corridors. And these are just all provided, again, customized for Sierra Space based on GNC corridor limitations that they provided to us. As we're coming up on the ISS, we can see this fun mesh ball thing. That is just rendered as a proximity zone in FreeFlyer. I'll pause this so that we can take a look at it. The blue or cyan is our approach ellipsoid, so that represents the direction of approach, and the red is the keep out sphere, and within that sphere, NASA requires that they are in charge of all upcoming operations. And as we get closer, we can just see our path, track through those safe corridors, and approach the ISS in a safe way. So this is a really fun display. I think this is really cool to look at, and we get a lot of nice visuals and a lot of good information about our current state of our rendezvous. So I'm going to go ahead and stop that. This one's still running, which is pretty funny. We can stop that directly from Atlas. And we'll move on to our last display. So I know I said relative motion was my favorite, but CCVT is also super cool. This display has a lot of information, and as the name indicated, it's our comms coverage and viewing, or comms and coverage viewing tool. And the purpose of this display is to give us insight into our contact schedule, into upcoming contacts, into whether our contact windows that we have planned are going to be made at the correct times, if our AOS or LOS is going to be offset from what we expect, all these good things. So we've got a lot of, again, similar options as to the other two displays. A really important one here is the comm schedule. We're going to see how that is rendered in the display in just a second. And once again, you can add all your ground stations, your DSN, MOAs, and TDRS. And you have a few random display options as well. So one more time, I'll hit run for CCVT. This one has a lot of data, so it's going to take just a minute to load up. And again, if for these purposes, we're running with ephemeris files just for simplicity for this demo, but we're also capable of processing real-time telemetry, which is going to be really important when you are trying to determine whether you're going to make your contacts as planned. So we're reading some antenna pattern files. Sierra Space has requested that we handle the antenna predictions through a custom algorithm that they've given to us and which we've been able to implement in FreeFlyer script. So that's one really handy thing, is that our scripting capability gives us that, that ability to really make something that's very customizable and does exactly what you want, instead of just kind of doing line of sight contact or some other just generic sensor evaluation. So now we got those antenna pattern files loaded in. We can start the display. We've got a 3D view up in the top left. And again, you can zoom in, you can zoom out, you can move that display as desired. We have 6 sensor views for the different sensors on the spacecraft for communications. This is just an azimuth and elevation plot of some of our TDRS assets with respect to the DreamChaser body frame. This big plot in the middle is our comm window plot. So all of these, Atlas is doing predictions for available comm windows with different assets, which are all listed here in the legend on the left. And then any of the bright green lines that you see are actually scheduled contacts, which are also displayed down in the comm schedule table below. This table uses a grid window object in FreeFlyer, I should say, to display upcoming contacts and their predicted AOS and LOS, whether we're getting any kind of danger because we're not going to make our acquisition of signal or anything like that. Over on the right, we're going to have some predictions for antenna swaps, and that is still in the works right now. So I'm going to stop this display and just jump back to our slides to finish off. Oops, sorry about that. Here we go. So these are the displays that we already saw: world map, relative motion, and CCVT. Very cool. We've had a lot of fun building these for Sierra Space, and we're looking forward to continue working with them to keep expanding these capabilities. And at this point, I'll just leave the floor open for questions. And I'll also just note that if you're interested in an Atlas display, if you think something like this would be beneficial for your mission, you can always reach out to our team at sales@ai-solutions.com, and they will get you all set up and give you all the information that you need to know in order to get an Atlas display going for your mission. And with that, I'll just say thank you.